All right, last example here. The probability of seeing a problem like this is very slim to none. If you do, it will be in the form of a multiple choice format, so you just got to pick the right one. So if you're getting a set of ordered pairs, not a graph, not an equation, you don't know if these points are connected or you don't know if they're just floating in space together. So when you're given an ordered pair, all you need to do is just list the x's and list the y's together. So here, just list the x's and list the y's. Obviously, keep them separate and use the bracket themes. So if you're talking about x, you can say, poop. You could say, oh, poop, that's funny. All right, so if you're talking about domain, your domain is going to be equal to, get your fancy little brackets that I'm absolutely horrendous at trying to draw, and then just list your x values in there. Make sure they're in order from least to greatest. That's probably the only important thing. Just make sure you go from least to greatest. So I'm just going to circle all the x values to make my life easier. -1, comma, 1, comma, 2, comma, 5, comma, 6. And this is good because none of those repeat, which would cause some serious problems with it being a function if it did have repeating x values. My range, just the y values that are left. Womp, womp, womp. Still really bad at making those. Y values, we have 8, we have 5, we have -9, we have 8. So we don't need to list 8 twice. Don't be redundant. I didn't really want to erase that part, just that one. And then we have 6. So the lowest one there is -9, followed by 5, followed by 6, and ended with 8. So only in situations like this could be listed. It wouldn't work for the graph or for the equation because there's all the values in between there, all the 0.5s, 0.52, 0.9s, all those decimals, all those infinite number of decimals. Whereas, like I said before, these ones being just points, we don't know if they're connected or not.